Hello students, so here we are with the question first of the exercise 1.2 for the chapter real numbers. So the question first is express each number as product of its prime factors, and the numbers have been provided. So starting with the A part, here the number provided is 140. In order to represent this number as product of its prime factors, I need to build factor tree for this number 140. So the number 140, I can see very clearly that this is an even number. Means if I take 2 out from this number 140, then I'll be left with 70. And again 70 is an even number, right? And again if I take 2 out from this number 70, then I'll be left with 35. And the number 35 is not an even number. So this number will not be divisible by 2 prime factor, and neither it is divisible by 3 prime factor, because the sum of 5 and 3 comes out to be 8. But we know that the number 35 is divisible by 5, because on dividing 35 with the number 5, I'll be getting 7. So means if I take a prime factor 5 out from this number 35, here I'll be left with 7. And we know that 7 is a prime factor itself. So at this stage, our factorization tree terminates. So the prime factors involved for this number 140 are 2, 2, 5 and 7. So I can represent the number 140 as 2 into 2 into 5 into 7, which can also be represented as 2 raised power 2 into 5 into 7. So this was about the A part. Now coming to the B part, here the number being provided is 156. Now I can see very clearly that this is an even number. Now if I again take 2 factor, there is 2 prime factor out from this number 156. So here I'll be left with 78. And we know 78 is an even number. So again if I take 2 prime factor out from this number, so here I'll be left with 39. Clearly 39 is not an even number, so I cannot take 2 prime factor out from this number. But 39 is divisible by 3. So if I take 3 prime factor out from this number, so here I'll be left with 13. And we know 13 is a prime factor itself. So the prime factors which are being involved in the number 156 are 2, 2, 3, 13. Means I can represent the number 156 as the product of its prime factors as 2 into 2 into 3 into 13, which is equals to 2 raised power 2 into 3 into 13. Right? Now coming to the C part, here the number being provided is 3825. Clearly the number is not an even number, so we cannot take a prime factor 2 out from this number. But the number 3825 is divisible by 3, because the sum of 3 plus 8 plus 2 plus 5 is equals to 18. So if I take a prime factor 3 out from this number, so here I'll be left with 1, 2, 7, 5. Again, this is not divisible by 2, but divisible by the prime factor 3. So again if I take 3 prime factor out from this number, so here I'll be left with 425. Now the number 425 is neither divisible by 2, because this is not an even number, nor divisible by 3, because the sum of 4 plus 2 plus 5 is equals to 11. but this number is divisible by 5. So if I take a prime factor 5 out from this number, so here I'll be left with 85. Okay, now again 85 number is divisible by the prime factor 5 because it has 5 in its unit place. Now here I'll be left with 17. Now again we can say very clearly that the number 17 is a prime factor itself. So I can represent the number 3825 as the product of its prime factor, where the factors are 3, 3, 5, 5 and 17. So this will be equal to 3 into 3 into 5 into 5 into 17, or I can write it as 3 raised power 2 into 5 raised power 2 into 17. So I have represented the number 3825 in terms of its product of its prime factors. Right. Now coming to the D part, here the number being provided is 5005. Now if I look at this number, this is not an even number, so I cannot take a prime factor 2 out from this number. And the sum, that is 5 plus 0 plus 0 plus 5 is equals to 10. So this number will also not be divisible by 3 prime factor. But as this number has 5 in its unit place, so I can easily take 5 out from this number. So here I will be left with 1001. Now if I look at the number 1001, so this number is neither divisible by 2 because this is not an even number, nor with 3. And this number is also not divisible by 5 because in its unit place it's 1, not 5 or 0, which is the divisibility rule of 5 says. So if we look for the prime factor 7 and divide the number 1001 with the prime factor 7, so here I'll be getting 143, means I can take a prime factor 7 out from this number. So here I'll be left with 143. Now the number 143 is not divisible by 2, not with 3, because the sum is 1 plus 4 plus 3 comes out to be 8. It's not divisible by 5 because unit place is not 5 or 0. It's not divisible by 7 also. But if I look for the prime factor 11, that 143 on dividing with the number 11 gives 13. Means this number is divisible by the prime factor 11. So I can take the prime factor 11 out from this number. So here I'll be left with 13. And as we know, 13 is a prime factor itself. So at this stage, the factor tree will terminate and 5005 can be represented as product of its prime factors as 5 into 7 into 11 into 13. Right. Now coming to the E part, here the number being provided is 7429. Now if I look this number, this is not an even number, means I cannot take the prime factor 2 out from this number, and the sum, that is 7 plus 4 plus 2 plus 9 comes out to be equal to 22. So this number will also not be divisible by 3. It's not divisible by 5 also because in its unit place it's 9. And coming to the 7 prime factor, then this number is also not divisible by the prime factor 7. And coming to the prime factor now, 11 here. So for the divisibility rule of 11 says 7 minus 4 plus 2 minus 9, which comes out to be, should be 0. Right. This is what the divisibility rule of 11 says. But as we can see very clearly that this 7 minus 4 plus 2 minus 9 is not equal to 0. So means this number is not divisible by the prime factor 11 as well. Now coming to the prime factor 17, I can easily take the prime factor 17 out from this number and I'll be left with 437. Now if I look at this number, then applying the divisibility rule of all the prime factors from 2 to 17, none of the prime factors will be taken out from this number 437. Now coming to the prime factor 19, I can easily take the prime number 19 out from this number and I'll be left with 23. And as we know, the 23 is a prime factor itself. So at this stage, the factor tree will terminate and 7429 will be equal to 17 into 19 into 23. That is, I can represent the number 7429 as the product of its prime factors which have been obtained from the factor tree. So this was about the question first of exercise 1.2. I hope this question is clear to all of you.